All right, we're going to look through our projectiles review for our test that is coming up. Number 1 says, which of the following would not be considered a projectile? So in order for something to be considered a projectile, it must be traveling through the air. So A says a cannonball thrown through the air. That is a projectile. B says a cannonball dropped from an airplane. It's traveling through the air. That's a projectile. C says a cannonball rolling down the hill. If it's rolling down the hill, it is not traveling through the air. D says a cannonball falls off a table. Once it falls off the table, it is traveling through the air. So the only one that is not a projectile is C, because it needs to be moving through the air. All right, number 2. At the instant a ball is thrown horizontally with a large force, an identical ball is dropped from the same height. So here you can see that there is a ball, 2 balls that are same size, shape, mass, everything, from the same height. If I drop one straight down vertically and another one at the same time horizontally, you'll notice, and you've seen in the videos, that they land at the same time, because gravity accelerates everything down at the same rate. Number 3, ignoring air resistance. Increasing a projectile's speed in a vertical direction has no effect on horizontal speed. So remember, we said that horizontal and vertical are independent of each other. So vertical velocity and horizontal velocity are independent. So it doesn't matter how fast one goes vertically, the horizontal motion is going to remain unchanged. And it doesn't matter how fast something goes horizontally, its vertical motion is going to remain unchanged. That they are completely independent of each other. Number 4, a projectile with a mass of 100 grams and another mass of 200 grams are fired from the same height with identical initial velocities. Which of the 2 projectiles will hit the ground first? Well, based off of the videos and demonstrations that we've done, you'll notice that both will land at the same time, because mass has no effect on how fast something falls. Gravity is unbiased. It's going to pull large masses down at the same rate, small masses down at the same rate. All objects will be pulled down at a rate of 9.8 meters per second squared. Mass does not matter. And number 5, I showed you the video, shoot the monkey. So I was asking, why is the air gun aimed directly at the monkey? Well, you saw that when your monkey was up in the tree, let's say that's my monkey, and my gun was down here, my gun had to be aimed directly at the monkey, because once this monkey started to fall, the bullet was fired, the bullet started to rise up and then come back down because of gravity. So eventually the bullet hit the monkey at a point along the monkey's path, but originally the gun had to be fired at the monkey. If I aimed higher than the monkey, then the bullet would fall short. If I aimed lower than the monkey, then the monkey and the bullet would not connect with each other. Okay, because everything falls down at the same rate, the bullet has to be aimed directly at the monkey in order to make contact. Number 6, what path does a projectile take while traveling through the air? So we've talked about how things travel up and then come back down along a curved path. If things are thrown horizontally, they also follow a curved path. So the path that they take is known as a parabola, or a parabolic curve. Okay, number 7. Which of the following is true about an object that's thrown into the air. Okay, A says the x velocity, so horizontal velocity is constant. Okay, that is true. Let's read the rest of them. The y velocity is constant. That is not true. I know that velocity slows down on the way up and speeds up on the way down. Both x and y are constant. Well, if y is not constant, then both of them cannot be constant. Both x and y accelerate at 9.8 meters per second squared. Remember, gravity doesn't pull things horizontally, so the x velocity is unaffected by gravity. X and y velocities are equal to each other. That means they are the same, and that is not true because vertically the velocity slows down on the way up and speeds up on the way down. So the best answer here would be A, the x velocity. Horizontal velocity is constant because it's not affected by gravity. All right, number 8. 8 and 9 are kind of referring to a similar scenario here, a question. If it's asking at what angle should a projectile be launched so that it travels a maximum vertical distance. So I want to achieve the greatest height. And in order to do that, I need to launch my projectile straight up at 90 degrees so that it achieves the greatest vertical distance. dy is vertical distance. Number 9 says, at what angle should a ball be hit to provide the travel the farthest horizontally? Okay, to achieve the greatest horizontal distance, an object needs to travel or be launched or hit at 45 degrees. At 45 degrees, my projectile achieves the greatest horizontal distance, dx, the maximum horizontal distance. It doesn't go as high as 90 degrees, but it certainly goes farther horizontally at 45 degrees. Number 10, at what point on a projectile's path does it have the least speed? So where is it going the slowest? Well, we've talked about this. If an object is going up and then coming back down, at its highest point, it's no longer going up, it has yet to come down, it's just changing direction, its vertical velocity is 0. If an object is launched horizontally, at its highest point, it's not going up, it's not coming down, it's only moving horizontally. Therefore, it has no vertical velocity. So it's at the highest points on either pathway that we have the least speed. Number 11, a plane is going to drop food and supplies to a village. Where should it drop the supplies? Well, we know that if the plane and the package are connected, then they are both traveling at the same speed. So in order to drop the package at the village, the package needs to be dropped before it reaches the village, so its momentum will carry it forward. So if the package is released here, then it's going to follow a parabolic curve and land right at the village. Okay? It should not be dropped straight down. If the plane is here and drops the package, it's not going to fall straight down. Okay? The package has velocity also. It will curve and reach past the village. So it needs to be dropped before so that that curve will land it in front of the village. Okay. Number 12 has a scenario here, and I'll zoom in a little bit on this diagram. It shows me, it says a cannonball is fired vertically at 40 meters per second out of the bed of the truck, traveling forward at a speed of 30 meters per second. So here's my truck, and there's going to be a cannonball fired out of the truck vertically at 40 meters per second. So that's Vy, vertical velocity, while the truck is driving horizontally 30 meters per second. Now, we did the demonstration in class with the cannon cart, and relative to the truck, where will the cannonball land when it falls? Well, if the cannonball and the truck are both traveling together at 30 meters per second, then once that cannonball is launched into the air, it is also going to travel horizontally, constant horizontal velocity, 30 meters per second. And eventually, it will land back inside the bed of the truck. It's going to land back inside the truck because the truck and the ball have the same horizontal velocity. So the cannonball will land inside the truck because horizontal velocity, Vx, is constant. So as long as the truck stays moving 30 meters per second, the cannonball will also be moving 30 meters per second and land back inside it. So here's the pathway that the cannonball is going to take. Nice curved parabola. And you know that objects that move up are decreasing in velocity. They're slowing down until they reach the highest point where they have no more vertical velocity. Once they change direction, they're going to come back down. Their velocity is going to increase in a negative direction. Okay, all while the horizontal velocity remains constant. So this parabola is symmetrical, meaning whatever's going on this side is equal to everything that's on this side. The only difference is the direction changes. So I'm going to use all that information to look at and complete the data table that's down here below. Okay, so the first thing that I'm going to do is I'm going to fill in all the information that I know based off of my concept. So I'm not going to calculate anything. I'm just going to fill in everything that I know based off of the scenario. First thing I know, something that's given to me, is the horizontal velocity. The horizontal velocity of the truck and the cannonball are both 30 meters per second. Okay, and I also know that horizontal velocity is constant. So even at the top, though it's not going up anymore vertically, it's still moving horizontally at 30 meters per second. And partway down, it's still moving horizontally 30 meters per second. Even all the way to the very end, at the far end at point C, it's still moving horizontally. Horizontal velocity remains constant. Okay. Another thing that remains constant is the acceleration of gravity vertically. Okay. Vertically, AY, I know that gravity is slowing it down on the way up. It's still slowing it down at the highest point. It's slowed it down so much that it's no longer going up, it's just changing direction. As it starts to come down, the acceleration of gravity is still negative 9.8 meters per second squared, and all the way at the very end of its pathway, the acceleration of gravity has not changed. It is still negative 9.8 meters per second squared. Okay. And one other constant all the way across the board is the horizontal acceleration. I know and we know that gravity does not pull things left or right. So horizontally, there is no acceleration. So it's going to be 0 all the way across. Okay, gravity only affects things that move vertically. Okay, so just based off of what information was given to me, I've already completed a big chunk of my data table. Now, one other thing that is given to me is the vertical velocity of the cannonball itself, Vy. Vy, the vertical velocity, was told to me, and it's 40 meters per second vertically. Now, because I know that my parabola is symmetrical, meaning whatever happens on this side is equal to what happens on this side, but in a negative downward direction. If my vertical velocity started off at a positive 40 here, then at the same point on the opposite side of the curve here, it's going to have the same velocity, but in a negative direction. So I'm going to go ahead and fill in the vertical velocity at the far end C as a negative 40 meters per second. Okay? Now, it tells me here that my vertical distance from the truck is 0, which means when it comes all the way back down and hits the ground at point C, it will also be 0. So I'm going to fill that in. Okay. Let's see, what else do we know? I know that at the highest point of the pathway, its vertical velocity will be 0. So vertically, at the top, its velocity is 0. So that's Vy at the top. Okay, it's no longer going up, it's not coming down, it's only changing direction at that point. Okay, now I filled in my table and I've recorded everything that was given to me. Okay, so now what I'm going to do is I'm going to look at what needs to be calculated and go from there. So first thing I'm looking at here on the first column is the resultant velocity. Okay, the resultant velocity, I'm going to scoot this up just a little bit. Okay, so the resultant velocity is VR squared. I'm sorry, VR equals horizontal velocity squared plus vertical velocity squared, all under the square root. So when I look up at the initial point, my horizontal velocity was 30. My vertical velocity was 40. So when I square 30 and I square 40, and then I take the square root of that answer, I should get a positive 50 meters per second. So that's the resultant velocity. That is the velocity of that ball along its curve. Now, remember our pathway is symmetrical. So whatever happens on the left happens on the right. If it's got a resultant velocity of 50 when it leaves the truck, then when it comes back into the truck at point C, it's going to have the same velocity, but in a negative direction. So negative 50 meters per second is my resultant velocity at the far end C. Okay, let's look at our top column. Okay, I can also determine my resultant velocity here. I can calculate it, or you might know that basic concept. If at the highest point it's got no vertical velocity, and the only velocity that it has at the top is horizontal velocity, then this must be the resultant velocity. And if you're not sure, you can still calculate it the same way, where VR equals 30 squared plus 0 squared. So 0 squared is 0, so all I'm left with is the square root of 30 squared. Well, 30 squared and then under the square root, they cancel each other out, which means my resultant velocity at the highest point is 30. Okay, now let's look at my horizontal distance, Let's figure out time, because time was our one variable that ties everything together. So, based off of what I know the initial velocity coming out of the truck vertically. I know the final velocity, the velocity at the top of the pathway. I know the acceleration of gravity, and I know time. So the equation that I would use is A equals VF minus VI divided by T. So in other words, negative 9.8 equals 0 minus 40 divided by T. When I solve for T, I get 4.08 seconds. So that's the time that it takes to reach the highest point. So if it takes 4.808 seconds to reach the highest point from the truck to the top, then it takes also 4.8 seconds to go from the top back down to the bottom. So to figure out the time it takes to complete its pathway, I'm going to take 4.08 times 2, and I should get 8.16 seconds. Okay? Now the last thing we need to solve for is the horizontal distance and the vertical distance. So horizontally, I only have one equation. It's Vx equals dx divided by t, where my horizontal velocity is 30. My horizontal distance is unknown, and my time to reach the top part took 4.08 seconds. When I cross multiply to solve for d, I get 122.45 meters. So if horizontally it traveled 122.45 meters to go from the truck to A, then from A to the C, it's going to travel the same distance. So overall, I have 122.45 times 2 equals 244.90 meters. Remember, the pathway is symmetrical. So if it travels a certain distance to go from the truck to A, then it travels the same distance to go from A to C. All right, the last thing I need here is the vertical distance. What is the height of that cannonball? Well, now that I've got all my variables, I know that I can use A equals VF squared minus VI squared, all divided by 2D. So A is a negative 9.8. VF at the highest point is 0. VI initially is 40. And I'm solving for D. So once I plug everything in, cross multiply, and get D by itself, I determine that the height that this cannonball reaches is 81.63 meters. All right, on number 13, we've got Letty, who's standing on the cliff above sharks, water, and sharp rocks below. She is kicked off a cliff, I know, very gruesome, with a horizontal velocity of 7 meters per second. She reaches a vertical speed of 50 meters per second before hitting the water. We need to figure out a few things. We need to figure out how long it's going to take her to reach the water, how high above the water she was when she was kicked, how far away from the cliff she will land, and her resultant velocity. All right, so I'm going to zoom in on the little figure here on the picture. I encourage you to draw the picture as well, because it'll most definitely help you identify what's going on. Okay, so let's see. So I know that she's kicked off. Let me zoom out, sorry. With a horizontal velocity of 7 meters per second, and she's reaching a vertical speed of 50 meters per second. Okay, so now I'm going to zoom in and write in some stuff. So I know her horizontal velocity is 7 meters per second. Okay, I know her vertical velocity right before she hits the ground. Her final vertical velocity, for that matter, is 50 meters per second. Now, the direction that she is heading is in a downward direction. So this 50 needs to be expressed as a negative 50 because she's moving down. Now, she's moving down because of gravity is negative 9.8. And what else do I know? I also know that her initial vertical velocity at the top, since she's only moving horizontally, her initial vertical velocity at the highest point is 0. Okay, so based off of the information that is given to me, I need to figure out how long, how high, how far, and the resultant velocity. So when it asks me for how long it's going to take, it's asking me for time. So the time is what I need to solve for. Okay, so based off of the information that I have, like the final vertical velocity, the initial vertical velocity, the acceleration of gravity, I can determine time. Now, the only horizontal component I know is the horizontal velocity. Okay? So I can't calculate time or horizontal distance because I don't know anything else other than horizontal velocity. Okay, so I can't use Vx equals dx over t to solve for time. I need to use the equation that has Vi, Vf, a, and t. And that equation is a equals Vf minus Vi divided by t, where a is a negative 9.8, Vf is a negative 50, Vi is 0, and t is what we're solving for. Okay? So when I cross multiply the t and the negative 9.8, I get a negative 9.8 t, and negative 50 minus 0 is simply just a negative 50. Okay? My last step here is to get t by itself. So what I'm going to do is I'm going to take the negative 9.8 and I'm going to divide it to the other side. And when I divide it to the other side, I get t all by itself. And a negative 50 divided by a negative 9.8 gives me 5.10 seconds. So it's going to take her 5.10 seconds to fall to the water. Number 14 says, how high above the water was she when she was kicked? So I want to measure from the water to the top of the cliff. That is a vertical measurement. That's a vertical distance. So how high above the water is asking me for dy. dy is unknown. Okay, so again, I cannot use a horizontal equation because I am measuring a vertical component. So the only component that allow me to solve for d when I know Vf, Vi, and A is A equals Vf squared minus Vi squared divided by 2 times d. And this is a vertical distance. That's what we're solving for. So I'll label it dy. So I'm going to substitute a negative 9.8 for a, negative 50 squared for VF, 0 squared for VI, divided by 2 times my vertical distance, dy, okay? So, like the first problem up here, I'm going to start off by cross multiplying 2d by negative 9.8. And when I cross multiply those, I get a negative 19.6 d, or 19.6 dy, equals, and then over here I've got 0 squared, which is 0, and 50 squared, which is 2500, but it's a negative 50 squared, so that gives me a negative 2500. So my next step to get d by itself, if d is being multiplied by negative 19.6, I've got to divide it to the other side. And when I divide it to the other side, I get dy all by itself. And I get negative 2500 divided by a negative 19.6 gives me 127.55 meters was her height above the water. Okay, and number 15 is asking me how far away from the cliff she will land. So she's landing here. It's asking me how far away here will she land. So what's being measured, this, just to recap, is a vertical distance. From here to where she lands is a horizontal distance. And that's what I want to measure. So I'm measuring how far away. That is a horizontal distance. Now, there's only one horizontal equation that we know, and it's Vx, horizontal velocity, equals horizontal distance divided by time. So the horizontal velocity was something that was given to me up in the problem, and it is 7. Horizontal distance is what we're solving for, and time is something that I calculated up above, and it was 5.10 seconds. So when I cross multiply 5.10 times 7, I get 35.7. I'm sorry. I was right the first time. 35.7 meters is my horizontal distance. Okay, now the last one associated with this problem is number 16, and 16 is asking for resultant velocity. And resultant velocity was how fast they're going over the curve or through the curve. So we label this as VR. There's only one equation for VR, and it's VR equals Vx squared plus Vy squared, all under the square root. So it's the square of the horizontal velocity plus the square of the vertical velocity, and then square rooted at the end. So VR is equal to, my horizontal velocity was given to me, and it is 7 squared. The vertical velocity right as she enters the ground is negative 50 squared, all under the square root. Now, if you get a negative under the square root, you will not be able to get an answer. So calculate it as if it is a positive, and when I calculate it, I get 50.49 meters per second. I know she's heading in a downward direction, so I need to add a negative in front of that. So negative 50.49 meters per second is her resultant velocity. Okay, on to the next one. So now I've got another scenario here where Carlos serves a tennis ball. And he strikes the ball while it's 2 meters from the ground. The ball travels 25 meters forward before striking the ground. How long will it take to hit the ground? How fast is the ball moving horizontally? How fast is the ball moving vertically? So I'm going to zoom in on the picture here and let's label some things. Okay, so here's my ball. And it's being hit horizontally, and it's eventually going to hit the ground. It's following this curved path called a parabola, and here's the ground. So it tells me right off the bat that it's 2 meters from the ground. So what it's measuring is the vertical distance. So dy is 2 meters. And it says it's hit 25 meters forward. So that tells me the horizontal distance is 25 meters. Okay, I also know that gravity is a negative 9.8. And I know vertically, the initial vertical velocity is 0. Okay, it's not going up or down at this point, it's only moving horizontally. Okay, so that is all the information that I know directly. Now I can proceed to solving for how long, how fast, horizontally, and vertically. Okay, so number 17 says how long will it take? So that is asking me for time. I need to figure out how much time it's going to take for the ball to hit the ground. Okay, so there are a few equations that have t in it, and I can use a variation of them, but the easiest one to solve for time, especially when I know the vertical distance or the height, is t equals 2 times dy, vertical distance, divided by the acceleration of gravity, all under the square root. So it looks like this. T equals 2 times my vertical distance we labeled was 2, divided by acceleration of gravity, which is negative 9.8. However, if I put a negative in here and try to take the square root, it's going to give me an error. I also know that time can never be negative. So either way, I need a positive answer. So I'm just going to calculate it as a positive 9.8 and take the square root. And once I type in the square root of 4 divided by 9.8, I get 0.64 seconds as the time it takes to fall. So when I get to number 8, it says how fast is it moving horizontally? So this is asking for horizontal velocity. And I know there's only one equation I can use to solve for horizontal velocity, and it's Vx equals dx divided by t. Where horizontal velocity is unknown, the horizontal distance, it went 25 meters forward in 0.64 seconds, giving me a horizontal velocity of 39.06 meters per second. And my last one is asking how fast vertically, so that is a vertical velocity, specifically my final vertical velocity. Okay? So this one is a vertical component, which means it's going to have the acceleration of gravity in it. So the best equation, when I have VF is unknown, VI, acceleration, and distance, is A equals VF squared minus VI squared divided by 2 times D. So when I substitute what I know, negative 9.8 goes in for A. Final velocity is what I'm solving for. Initial velocity vertically is 0. And 2 times my vertical distance, which is 2. Okay? So we know that 2 times 2 is 4. So when I cross multiply 4 by negative 9.8, I get a negative 39.2 equals, I know 0 squared is 0, so VF squared minus nothing is just VF squared. And my last step is to take the square root of VF so that I can get VF by itself. Now, when you take the square root of this side and take the square root of this side, you cannot take a square root of a negative. We just mentioned that up above. So the negative only tells me it's moving down. So remove the negative for the calculation and plug the negative back in your final answer. So when I take the square root of a positive 39.2, I get 6.26 meters per second as my final velocity. But I can't forget it's moving in a downward direction, so I need a negative sign out in front. So it's a negative 6.26 meters per second. And lastly here, got a few concepts. The first one says, describe the horizontal velocity vector of a projectile launched at an angle through the air. So I want to describe horizontal velocity. Well, since gravity doesn't affect things, it doesn't pull things horizontally, horizontal velocity is unaffected by gravity, and it remains constant. Okay, horizontal velocity, Vx, is constant, no matter what, even at the highest point. And the next one, it says describe the vertical velocity vector of a projectile launched at an angle through the air. So now I want to describe vertical velocity. Well, as we talked about in free fall, the vertical velocity decreases as it moves up. At its highest point, the vertical velocity is 0. And on the way down, its vertical velocity increases. So if you've got a path that looks like this, it's going to slow down on the way up, change directions at the top where its velocity is 0, and on the way down, it's going to speed up again. So the vertical velocity is affected by gravity, causing it to slow down, change direction, speed up. Horizontal velocity remains constant that entire time. Describe the acceleration. Okay, describe the acceleration vector of a projectile launched at an angle through the air. The acceleration due to gravity vertically remains constant. Okay, we're talking about gravity here. Gravity doesn't change whether it's launched at a 90-degree angle, a 45-degree angle, a small mass, a large mass. The acceleration of gravity remains constant. It does not change. It's always negative 9.8 meters per second squared. And my last question here, what is the difference between a projectile launched at an angle of 70 degrees compared to one launched at an angle of 30 degrees? Consider height, time, and distance. Well, as an angle increases from 45 degrees, the height and time increase. So my object is going to move higher up into the air, which means it's going to take longer to come back down. However, the horizontal distance decreases. It gets shorter. It doesn't go as far horizontally. So those are angles like 50, 60, 70, 80, 90, increasing from 45. As angles decrease from 45, the height and time decreases, and the horizontal distance also decreases. So as we go from 45 down to 40 to 30 to 20 to 10, the height, the projectile, is not going to go as high. And the time it takes to go, travel that distance, is also not going to be that much because it's not going so high. However, the horizontal velocity will still decrease just like it did greater than 45. Okay, 45 degrees is going to give me the maximum horizontal distance. So anything greater than 45 or anything less than 45 is going to give me less of a horizontal distance.